In the previous lecture, we have stopped in the equation number 27, that is the expression for wave function xi of x equal to b naught e to the power ikx plus gamma bn e to the power knx. See, and if suppose for one of the values of kn, what happens? K is equal to kn. What happens now? Xi of x is equal to b naught into e to the power ikx plus gamma into bn into e to the power minus ikx. That means what? This indicates e to the power ikx. It is the forwarding wave. E to the power minus ikx, that indicates the wave which is moving in the opposite direction. So as I already told, so forwarding wave and opposite moving waves superimposed and forming a standing wave. Now what you have to do is, now you have to consider the Schrodinger's wave equation, that is d square xi by dx square plus k naught square plus gamma f of x into xi of x is equal to 0. In this expression, you have to substitute for d square xi by dx square, and also you have to substitute for xi of x, and also you have to replace f of x by its expression. So as you know, f of x is nothing but sigma n is equal to minus infinity to plus infinity. So Cn into e to the power minus 2 pi inx by a. So now to get this, you have to consider the equation number 27 and you have to differentiate dxi by dx, that is equal to b naught ik e to the power ikx plus gamma bn ikn e to the power iknx. Next you have to differentiate again with respect to x, that becomes d square xi by dx square, that is equal to b naught into ik whole square, I square is minus, therefore minus b naught k square into e to the power ikx. Similarly here, differentiation of e to the power iknx is ikn into e to the power iknx, ikn whole square, I square is minus 1, therefore it is minus gamma bn kn square into e to the power iknx. So now you substitute the value of d square xi by dx square and xi of x and also f of x in the Schrodinger's wave equation. You will get minus b naught k square e to the power ikx minus gamma bn kn square e to the power iknx plus this k naught square into xi of x, multiply and substitute k naught square into b naught e to the power ikx plus gamma bn into k naught square e to the power iknx plus next term, that is gamma into f of x into xi of x. Here f of x is equal to this much, first term, plus gamma into b naught into f of x, that is Cn e to the power minus 2 pi inx by a Okay, into e to the power ikx plus next term, this one you have to, second term you have to consider. So what happens? Gamma, and here again the expression contains gamma. So what happens? Gamma square into Bn sigma Cn dash into e to the power minus 2 pi In dash x by a into e to the power iknx is equal to 0. See, I have just changed the notation by n dash because kn is nothing but k minus 2 pi n by a. This integer and the integer here we are using need not be same, only to differentiate. Same situation arose earlier also. Because of that, just n is replaced by n dash. That is equal to 0. So now what you have to do is, see in this wherever you are finding first term, now I am considering, see this one and the third one collecting together, taking the common factor outside, we are getting b naught into k naught square minus k square into e to the power ikx plus second one, see you can consider this term and this one together, you are getting gamma bn into k naught square minus kn square into e to the power iknx plus here you are getting gamma into b naught into sigma Cn dash, right, Cn dash. So here it is the third term, no need, here only one, Cn into e to the power I k minus 2 pi n by a means kn. Therefore I can write this one as iknx. So plus last term, that is gamma square into bn sigma Cn dash e to the power minus, e to the power I k 2 pi n can be written as how? K minus kn can be written as k minus 2 pi n by a minus 2 pi n dash by a into x. This is equal to 0. This is equation number 28. So now what you have to do is you have to consider the equation number 28, and this equation number 28 is multiplied with e to the power minus ikx and integrate it from 0 to a. So now what you have to do, equation number 28 is multiplied with e to the power minus ikx, integrate from 0 to a. Okay, what happens in the single step, just you can see here. See, when you are doing this, what happens, just observe here, e to the power minus ikx into e to the power ikx, e to the power 0, e to the power 0 is 1, integration of dx is x, upper limit is a. Therefore you are getting now b naught k naught square minus k square into a, right. Then what happens to the second and third term, right? See, here when you consider second term, kn minus k, right? It becomes again, this integration becomes 0. Third term, that is also becomes 0. So integration of second and third term reduces to 0. But when you consider the fourth term, it also 0 except for n is equal to minus n dash, or you can say n dash is equal to minus n, n1. N is equal to minus n dash, or n dash is equal to minus n. That is, when n dash is equal to minus n, what happens? This term reduces to 0. Then remaining is e to the power ikx, that is multiplied with e to the power minus ikx. So it becomes, integration becomes dx. So upper limit is a, lower limit is 0, integration of dx is x, put the limits, then you are getting the terms as gamma square bn into cn dash. I am just writing this one as a cn star, already we have written this earlier also, into a is equal to 0, or a get cancelled. I can write this one as k naught square minus k square into b naught plus gamma square cn star into bn is equal to 0. This is equation number 29. So now, next step is you have to consider the equation number 28. This is multiplied with e to the power minus ikn x. Then integrate from 0 to a. So what happens when you do this? First term reduces to 0. In the second case, just to see what are the terms retains, that one you have to evaluate. Right. So second term also reduces to 0. Third term gamma into cn. Right. See what you are getting. Just to see here. Gamma into this kn minus k. Right. So this is kn is nothing but k minus 2 pi n by a, right, minus k. So here what happens when you are considering to this? You are multiplying with the e to the power iknx. Therefore what happens? E to the power 0 this is. So what happens? E to the power 0 is 1. Its integration is of dx is x, upper limit is a, lower limit is 0. So what you are getting now, considering to the third term, gamma into, I am writing this cn into b naught, right. Similarly, when you are considering to this, I am coming to this second term now. So because I want the same order, b naught first, therefore I have considered the third term first. So first and last term reduces to 0. Here it becomes e to the power 0. The remaining term is what? Plus gamma into k naught square minus k square into bn equal to 0. This is the equation number 30 you are getting. Okay. So now for non-zero. So for non-zero values of b naught and bn, the coefficients of b naught and bn you have to consider and write in its determinate form. For non-zero value of b naught and bn, determinant this k naught square minus k square. Below you have gamma here gamma square into cn star Then you have here Cn into gamma get cancelled. So here what happens? Cn into k naught square minus k square is equal to 0. Now you can simplify the determinant that k naught square minus k square into here it is kn square, just to observe the equation. So here it becomes k naught square minus kn square, k naught square minus kn square minus what you are getting, gamma square Cn into Cn star, this is equal to 0. So 16. So is equal to 0. Now just multiply this. You are getting now k naught to the power 4 minus k naught square, kn square minus k square, k naught square minus k square, kn square minus gamma square into Cn star into Cn. This is equal to 0. So you can write this one as k naught to the power 4 minus k naught square is common. K naught, you can write this one as kn square, or this minus is taken, k square plus kn square into k naught square and minus into minus, here it is plus k square kn square minus gamma square Cn star, Cn is equal to 0. So therefore this is the quadratic equation in k naught square. Its solution is k naught square is equal to half into minus b, minus into minus plus, it becomes k square plus kn square plus or minus square root of b square, right? So that is k square plus kn square whole square, right, minus b square minus 4ac, right, 4ac, this is c, k square into kn square minus into minus plus 4 gamma square Cn star Cn, right. This is the solution